Number 11, two blocks A of mass 10 kg and B of mass 30 kg are side by side and in contact. They are pushed along a smooth floor. That means there is no friction, okay, on the floor under the action of a constant force F, okay, of magnitude 200 Newton applied to object A, okay, as shown in figure. Determine the acceleration of the blocks, and B, the force exerted by A on B. Okay, so you have to determine the acceleration and the force exerted by A on B. So for question A, the acceleration of the blocks, okay, so we may apply net force X equals to MA because this block accelerate at X component. So net force X equals MA. So for this system, there's only a single force F, okay, F, and the mass here is the masses of block A and block B, okay, and they will accelerate with same acceleration A, okay. So substitute force F 200 Newton and mass A 10 kg and mass B 30 kg. So you can determine the acceleration A. So it is 200 over 40. 200 over 40 equals to 5. Okay, 5 meter per second squared. Okay, so this is for question A. You have to determine the acceleration. And then for question B, force exerted by A on B. That means force on B by A. Okay, where F AB means force on B by A, and FBA is force on A by B. Okay, so this is the Newton's third law. Okay, every action has reaction, same magnitude but opposite direction. So force on B by A, okay, force on B by A is equals to force on A by B, same magnitude but opposite direction, okay, negative, like this. Okay, so when we want to find the force exerted by A on B, so we have to consider, okay, force on object B, okay, force on object B. So object B, okay, so B, force on object B, okay, so A will push B, so this is force on B by A, and for object A, B will push A, so this is force on A by B. Okay, so they are actually cancel each other. Okay, okay, so for object B, there is only single force, okay, which is force on B by A. So apply net force X equals to MA. Okay, so only force on B by A, okay, equals to mass on B, okay, times acceleration. So force on B by A is mass B is 30 and the acceleration is 5, so it is equals to 150 Newton. Okay, so we can check, okay, we can check is the force on B by A is 150 Newton, okay, by using object A, okay, by using object A. Okay, by using object A, so we have to consider object A. So force on object A is the force F, okay, the push force F here, okay, this one, and the force on A by B. Okay, force on A by B, because B push A. Okay, so we can also apply net force X equals to MA. Okay, so object A accelerate to the right. Okay, object B also accelerate to the right. Okay, so F is in the same direction of A, so it is positive, and force on A by B is opposite of acceleration, so it is negative. Okay, this one is mass of object A. Okay, so substitute F, where F is 200 Newton, and then force on B by A is unknown, and mass A is 10 kilogram, and the acceleration is 5. So force on A by B is equals to 150 Newton. Okay, to the left. Okay, we can see from here. Okay, from here it is to the left. And force on B by A is to the right. Okay, maybe I can draw free body diagram for force on B by A. Okay, only this force on B by A. Okay, so it is to the right, so they are equals. Okay, force on A by force on A by B, force on B by A is equals to force on A by B. Okay, they are equals. Okay, but opposite direction. Okay, number 12, three identical cubes. That means they have same masses. Each of mass 2 kg are at rest in straight line on a smooth horizontal floor. That means there is no friction in contact of each other, as shown. A horizontal 12 Newton force. Okay, so this is the force F. Act on cube X. Okay, so we have cube X, Y, and Z. Cube X, Y, and Z here. Determine the acceleration of the cubes. Okay, so this cube accelerate to the right. Okay, accelerate to the right because force to the right. Okay, force F or push force to the right. Okay, so it accelerates to the right. So we may apply Newton's law. Net force X equals to ma. So in this system, we have only single force F for X, Y, and Z. So F equals to mass here is mass of X. Okay, mass X plus mass Y plus mass Z. Okay, so they will accelerate with same acceleration A. Okay, so you can substitute force F, 12 Newton, mass X is 2 kg, Y 2 kg, and Z 2 kg. Because they are identical, that means they have same masses, and acceleration is the unknown that you have to find. So acceleration equals to 12 over 6 equals to 2 meter per second squared. Okay, this is question A. Question B, the resultant force acting on each cube. Okay, so let us solve by one by one. For cube X, okay, cube X, net force X equals to mass X times acceleration of cube X. So mass X is 2 kg and acceleration of cube X is 2. So for Newton, and then for cube Y, okay, net force x equals to mass y times a, where mass cube y is 2 and acceleration of object y is 2, so it is also 4 Newton. And then for cube z, net force x equals to ma, and this is mass of object z, okay, cube z. So mass z is 2 kilogram and acceleration of cube z is also 2 meter per second squared. So resultant force for cube z is also 4 Newton. And then for question C, the force acting on y, okay, force acting on y due to the pushing by x. Okay, so we have to consider cube y. Okay, cube y. So for cube y, okay, this is cube y. Okay, z is on the right side. Okay, z is on the right side. So z push y. Okay, z push y. So this is force on y by z. And then on the left side is object x or cube x. So x push y. So this is force on y due to x. Okay, force on y due to x. Okay. Okay, so we want to find force on y due to x. Okay, this one. Okay, so this like this. Net force x equals to mass y times a. Okay, so we have force on y due to x minus force on y due to z equals to mass y times a. But we don't know the value of force on y due to z. Okay, so we can determine from consider object or cube z. Okay, for cube z, okay, this is cube z, okay, here. So on left side of object or cube z is object y. So object y or cube y push cube z. Okay, so this is force on z by y. Okay, so we can apply net force x equals to ma za. So single force here is force on z by y, so it equals to mz. Mass z is 2, okay, times acceleration is 2, so this 4 Newton, where force on y by z is equals to force on z by y. Okay, same magnitude but opposite direction, so it is 4 Newton. So we can substitute the value here. Okay, so xy is the unknown that you have to find. Okay, minus zy is 4. Okay, and then mass y is 2 times acceleration 2. So force on y by x is 8 Newton. Okay, 8 Newton. Okay, 8 Newton. Okay, it's like this. And you also can determine force on y by force on y by x by consider object x. Okay, it is like this. Okay, like this. We can consider object x. Okay, cube x. For cube x, it has push force to the right, and then on its right is cube y, so y push x, so this is force on x due to y. Okay, then we can apply net force x equals to ma, so F minus F xy equals to xa. So force F here is 12 minus Fyx equals to 2 times 2. So force on x by y is 12 minus 4, 8 Newton. Okay, so this is force on x by y. So force on y by x is equal, force on y by x is equals to force on x by y. So it's also equals to 8 Newton. But force on x by y is to the left, and then this one is to the right. Okay.